Okay, so today I'm solving Leetcode daily, separate squares one. So this one is a clearly binary search problem. The only thing is like to do that carefully and like calculate the area of the squares below the line and area of the squares above the line, and like do the binary search. Constraints like tell me that binary search is possible here. So the binary search is gonna be n log n, and yeah, that's gonna be it. And let me just code it quickly. So I'll have this let's called let's call it function def calc, and then it will accept the level and the integer, then it will accept the squares as a list of integers, and then it will return two values. It's gonna be a list of integer, and the first one gonna be above the line and the second one gonna be below the line area. And then I'm gonna go for squares. Okay, so for the calculation I'm gonna go for square in squares. I'll do there are like three possible cases: the square is below the line, the square is above the line, and the square is split by the line. So, and then here I'll have this, say, double float. So let's assume it's the square. How I can check if the square is above the line or below the line? So let me check what do we have. So we have x and y coordinate to the bottom left point. So if I try to draw that, well, I have this x and y. It's called xi, yi, and then I have li as a length li. So if the level is above, if yi plus li, if it's less than or equal level, that's the first case. First one. In this case, rectangle is below line. Second case, if the yi plus li is greater than L and yi is less or equal than L. In this case, rectangle is in between. And the third case is gonna be the following. The third one case, so it's gonna be yi is greater than L. This rectangle is above line. So now it's like pretty much continuous. So I'll do so if square 1 plus square 2, if it's less or equal level, then I'll update rectangle is below the line. So I'll have this above, let's say high area and then low area is equal 0 initially, and then if the square y plus length of the square is less than level, then it means I should update low area plus equal square 1 multiplied by square 2, square 0 multiplied by square 1. If square 1 plus square 2 is greater than level, and square 2 or square 1 is less or equal level, then I'm gonna update the low area and the high area. And low area, so the length gonna be at the level, so the lower part gonna be so the upper part gonna be li, so li is gonna be square 2 minus plus square 1 minus level, and it's gonna be the upper side. So like let's coordinate of the upside. Let's say we have here level, this one is yi, this is yi plus li, and then the size of this one gonna be, if I so I know that this is a level, and then yi plus lower size equals level. So level minus yi gonna be lower size. Yi minus level. Oh no, level minus yi. Level minus yi gonna be lower size. So level minus yi gonna be level minus square 1. And that's gonna be the size of the lower one. So the low area plus equal this one multiplied by square 0. And the high area gonna be the same plus equal, and then in this case I need to subtract size li minus level minus yi. So I need to copy this one and then subtract it from the square 2 minus, and then this one multiplied by the square 1, oh square 0, multiplied by square 0, and then else case only high area should be updated. So it's going to be high area plus equal square 0 multiplied by square 1. And then in the end I'm gonna return high area, low area. Then I'm gonna do the binary search. So I'm gonna have this good with the y maximum 10 to the power of 9. Okay, I'll do this, let's say good, I'm gonna be good gonna be let's take maximum of the for square in squares, I'll do square 0, no, square 1 plus square 2. And then I'll do bad gonna be equal to 0. Then while good minus bad is called delta precision. Delta equals 0.0 to the power of 5. Have this precision, and then while ups delta, while ups difference between good and bad is greater or equal to delta, I'll do the following. Middle gonna be bad plus good minus bad over 2, and then I'm gonna check, okay, high area, low area gonna be equal, calling this calc function is called calculate. So it's calculate at the level m and then squares, and then yep, and then squares, and then I'm gonna check if the, so I need to take a decision if I should go up and down. So if high area is less than low area, then I'll go, first of all, like if the high area is equal to low area, I'm gonna go and just escape return level, like return m. If high area less than low area, then I need to do the following. What I'm gonna do, something like, so if the high area is less than low area, then it means I need to move level upper. So I'll have this well, kind of bad is equal to m, else I'm gonna have good is equal to m, and then in the end I'm gonna return level. Or like maybe something like this, else return good. Okay, it's going to be float here and then float here. Okay, interesting. 0.001. Why? Do I exit immediately here? Okay, so let's check. So if the high area is lower than the low area, oh, it means that I need to vice versa. So if there's a smaller, it means that I need to move the level down so that high area becomes like more closer to the low area, and by moving this down level, I need to go good is equal m, so that next middle gonna be lower. So good is equal m, and then bad is equal m in this case. Still no. Output 2.5, whereas it should be what should I return here? Oh, it's a horizontal line such that the total area of the square is above the line. Hmm. Why it is 2.5? Let's check again my algorithm. So high low area, if the square 1 plus square 2 if it's less than low level, then the low area is like this. If the square 1 plus the square 2 is greater than level, and then square 1 is and level is higher than the square 1, then low area gonna be level minus square 1, and then here gonna be square 2 minus length. In this case it should be minimum y coordinate. Okay, so first of all I need to go it's still not the right answer. So let's print this interim values. Print format, then high area, and then say low area. Good. Okay, let's check good. So I split at 3. Oh wow. I split at 3. Or let's say m. I'd split it at 1.5. So low area, high area becomes 4. That's something I have not expected. Low area is 0. Why if I split at 1.5? So I have high area, low area. And then here I go 0, 0, 1. Check it. So square, let's check this square. If square 1, so 0 plus 2, and the level is, it's not this one, but it shows square, okay, 0.01, okay, it's true, so left area gonna be, oh, okay, so it's square, okay, I got it, square 2 by square 2, and then square 2 by square 2, and then here gonna be this one multiplied by square 2, and then square 2 here. Yep, I messed up the formula actually. Okay, and then submit. Yahoo! So I wonder what people are doing here. If so first of all they got this total area, and then half of the area gonna be equal to the total. So they are basically changing, like sorting this array. Instead of like doing binary search, they are sorting, and like sorting is already n log n. And then if they have sorted, I assume that they find they go through this point of change array and check if there is one. So it's something like this, I assume. So they do. Okay, so they know so let's say they have like this all rectangles, and let's say they check the areas. They know the target. Let's say target is equal 12. So let's say this rectangle is 1 by 2. This one, let's say 2 by 2, and then this one gonna be 1 by 2, and this one gonna be 1 by 2. So total is gonna be 2 plus 4 plus 2, 6. Let's say 3 by 2 here. Oh, no, 2 by 2. So here 1 by 2 plus 2 by 2 by, well, that's gonna be 4 by 2. 4 by 2 is 8. And then here 2 by 2, 4. So total is 12. So what they do is like, they have this change points. So here it's like 2, and the next one gonna be at this level, let's say 4, and the next one at this level gonna be 6. Oh no, so here it was 6, and this one at this level gonna be 8, and then at this level gonna be 12. So they calculate this point of change based on, let's say, upper bound of the rectangles, and then they go from the start to the end and look for the 12 over 2 bound. So the 12 over 2 gonna be changed, so between 6 and between this and this. And then they can like explore if it's like on the edge, if it's like in between, and if it's in between, um, um, they'll probably find it kind of linearly. The question is like right now is okay, but here it's also this one is affected. This rectangle is affected. So probably point of change, they know not only include the lower part, but they also include the upper part. So here it's gonna be whatever like I have added, and then like yeah, it's quite interesting one. Point of change. So they are doing this plus L minus L. And then like somehow like they are accounting for the smart changes. Yeah, I'm gonna wrap up. It seems like this one is really interesting one. The time complexity of this one, because like there is still sort is gonna be n log n, but like I think sort is implemented here like in C. That's why it's faster in this case. But like total time complexity gonna be the same actually for this problem. What they say in the tutorial: binary search, binary search. Approach one. Approach to scanning line. Oh, that's interesting. So, oh, they do the sorting. Oh, that solution was actually from editorial. Okay, I'll read it on my free time. Okay.